What's up, everybody? This is Matt Brown with another IoT hacking video. On my desk, I have an automatic license plate reader that I have acquired from eBay. And these devices have been the topic of news articles recently discussing security vulnerabilities and privacy risks that are all associated to these police-deployed automatic license plate readers. So in this video, we are going to discuss all of those implications, and we're going to actually do some hardware hacking. And at the end of the video, we're going to show us having a root shell remotely via SSH on this device. And I have not modified it at all. This is the way I received this device from eBay. And so this is going to be a fun one. So let's look at some of the findings that a different device, an associated device, has been discovered. So this is, Motorola Solutions, and then Vigilant is kind of the brand name that this device goes under. And so these license plate reader devices, and so this finding here is actually related to a communications box, because the way that these systems here are meant to be deployed is you have actually multiple of them on a cop car, and then they feed via power over Ethernet into a laptop or some kind of communications box, some hub that will let you feed all that data and have one pane of glass, one interface that you can see all the results from if you get a license plate hit that is of interest, that's in some database that you have locally or that you subscribe to. You pay for a service to have, a service of sketchy license plates that you want to alert on. I don't know any of that side of things, but what we do on this channel, my name is Matt Brown. I do hardware security, I do IoT pen testing as my day job, and then we do that on this channel as well and do some fun reverse engineering of devices like this. So we're actually gonna go back to my computer here, and the first thing we're gonna do is we're going to look at this device over the network. So it's got a static IP address that's actually like printed on a label on the device. When we go over to the desk, you'll see that. So here, I have run a simple Nmap scan, and you can already see some issues that we have here. So just to prove to you that this device is online, I left that Nmap scan sitting up there. There we go. It's going to run an Nmap scan, and we get these results, right? So right away, we see port 22. That is the SSH port. That is super interesting that SSH is open on this device. That is not best practices for devices that are deployed in the field and that may be on an untrusted network. There's also some other interesting things. 554 is like the Samba, so we could potentially like mount a file share on the device. We'll look at that in a little bit later as well. RTSP, so obviously this is a camera, and so being able to like get a video stream potentially from the device on that port. And then there's some, web and some other custom TCP ports that we see there, and we'll get a taste in this video of what some of those services might be, and in future videos we're going to do some reverse engineering to find out what those services do exactly. So, but in this video we're going to be really targeting this SSH service. So, and then there's just some other fun stuff too. So like, if I go over here and we look in Wireshark, we see like all the time that this device is just like trying to send data to this random, UDP service out on the public internet at this IP address. This is kind of a spoiler ahead of the video, but I've done some like firmware analysis of this device, and that IP is like hard coded into the firmware. It's hard coded to just like phone home and to send all of this information in clear text, by the way, home to its server. Let's go ahead and let's take one of these packets and just say follow UDP stream. Oh, of course, whatever. But obviously you see that it's sending the board name, and we get our first hint that there's something a little weird about this device. So here it's sending in this JSON data. Board name is Raspberry Pi. All right, I wonder what we're gonna find inside of this license plate reader. Okay, and it's also got other stuff about like the MAC address, the machine ID. Again, we get this information about this IP address that's hard coded on the device. So let's clear this up and let's head over to the desk. get our microscope out of the way to start with. So I have this partially deconstructed. So the first thing we're going to do for our hardware analysis, we're going to power that off. We're going to unplug our Ethernet. Here you can see that printed on, that's just kind of like a label. It's got this static IP address assigned to the device. And then we've got some, barcode with a serial number. Here we see that Vigilant Solutions, again, I don't know if they were purchased by Motorola or if they're just, a brand of Motorola, but that's the company name that makes this device underneath the Motorola brand. And here, so we can kind of start to take this device apart. And so here we see we've got a bunch of IR illuminators. I don't know if you saw on the desk earlier, but those are like lighten up. So those are probably like infrared for night, for seeing at night. And then we have these two cameras here. And so on the back side, I'm gonna very carefully take out this, because this is where the power over Ethernet connects. And so now we're going to remove. We're going to slide this out. And then I'm going to keep track of which orientation this is. And I'm going to plug this back in so that we can just later power up this device when it is, when we power it up again, it'll be ready to go. There we go. Okay, so you can see those pins that go through there and connect to the Ethernet port. So underneath here we have some interesting things, but again, we kind of got a bit of a spoiler when we looked at that UDP traffic. And so right here, if I clear away this stuff here, this is kind of like a DIMM slot, just like a RAM chip. We can see that we have, if I get it in focus, camera, a Raspberry Pi Compute Module 3. So this component right here is a stock Raspberry Pi Compute Module, and it is the one that comes with a flash chip on it. You can get the light version that doesn't come with a flash chip. And so the rest of these components are custom in here, right? And so let's look at this compute module, because this is going to be the most interesting part of this device. So we're going to swap over to our microscope. Let's get some light and zoom out here. And we'll get it in focus. So here on this side, again, we see that identifier that this is a Raspberry Pi 3, the compute module version. We have the CPU on this side. Flipping the chip over, right here, we have the eMMC flash chip right here. So at this point, if this was a normal device, what I would have to do is I would have to desolder this from the board, and in order to dump this firmware, I would have to desolder from the board, and then if I wanted it to function again, I would have to perform a pretty risky operation to reball all of the pads that are underneath here, and to solder this back onto this board to get it functional again. But the cool thing about the Raspberry Pi ecosystem is that we're not going to have to do that, because this is a really common device here. And then I went out and I bought this. This is a Raspberry Pi Compute module breakout board. So this is really for development purposes. So what we can do is we can plug this in here back into that DIMM slot, and now we can run some code on our computer and connect it up to this so we have like slave, so that's going to be the data line to our computer, and then we have power. So with this board, the way we boot it up into its special as a slave device, we're not going to boot the code on the Raspberry Pi, is by first making sure that the slave is plugged into our computer, and then we're going to power on the device. So once we do that, then we can come over to our computer here, and let's see what's going on here. And we can see that, yeah, okay, so this is perfect here, right? So we can see here, you know, BCM 2710, that's the CPU that the Raspberry Pi has. And it says boot. So it hasn't fully booted up this device. It's in its like boot mode. I don't completely understand how all that works. I'm just following some instructions here. But then what we can do is we can come over here to GitHub. And this project here, Usbboot, by the Raspberry Pi project here, we can use this code to turn this, you know, compute module and have it show up as a removable, like a flash drive, right? Like some kind of a, you know, a mass storage device. And then we can see all the partitions on the device and then mount them one by one and copy over the firmware. So all without desoldering or anything like that. So that's going to be a lot more preferential. So we're going to follow the Linux instructions here. So I already have all of these requirements. The only real requirement here, I mean, is like, yeah, you need libusb. I already have that installed in my system. So we're going to come over here and we're going to say, we're just going to run this command and it's going to clone the Usbboot project as well as all of its dependencies. And so then we're just going to let that download and everything like that. And then we're going to go into the directory and run make. And then we just get to run this program just like that. All right, let's go back. It's going to take a minute, isn't it? So while we're waiting for that, you know, let's talk about what we're going to do. So then the next thing we're going to do is we're going to DD out the file system into two partitions. So I've already done that, and we're going to walk through that in a minute with one partition, but not the other partition, because frankly, this other partition is quite large. It is 2.4 gigs, and it took me about 5 or 6 minutes to do that. Okay, cool. We are ready to go. So let's go into this Usbboot folder, and we can run make. And if I recall correctly, it didn't take that long. So now we run sudo rpi boot, and while we're doing that, let's see what happens here in dmessage. And so we run the boot code. Now it's showing up as a new device, as a USB storage device, and now we have a new, you know, device showing up under SDC. So it's going to be under dev/dev/SDC. And we have 2 partitions. So this is really cool. So what we can do here is ls block. And so here you can see that I have a new disk here, right? And so what we can do to copy this out, I've already got it copied out, but I will show you what we do is we use dd, we go dev/dev SDC1. So I'm just going to do the bootloader, the small partition. Like I said, we're not going to redo the large one here. And we're going to say out file, and we're just going to call this like test.bin. And now we're going to say block size of 1 meg, because then it'll go faster. So we should have that copied out. All right, it's done. And so you can see here, test, yeah, it's the same here. And I mean, I don't think I modified this, but it is possible. I did. Okay, I mounted it as writable, and that's why you're seeing what you're seeing there. So I'm pretty sure that read successfully. Now, what we're gonna do is we want to mount these things. So, okay, let's take a look at our 2 you know, partitions here. What the heck? Oh, I call them part. All right, so we have partition 1 is, yeah, it's this boot sector thing, right? So this is a FAT32 file system. So that is obviously going to be, think about it, it's a Raspberry Pi, right? If you've ever set up a Raspberry Pi, that's like the boot directory where all of the custom, you know, Raspberry Pi boot things, there's going to be a config file that you could like enable UART, but we don't need to do that. We're going to have a better way to get a shell on this device. But here we see the ext4 file system. Again, it's the large file system. This is clearly our root file system. And so what we're going to do is I have a directory that I made here called mount. And so I'll show you right now. It's just empty. And so we're going to run sudo mount dev. Wait, no. We're not going to mount. We're not going to mount it from the live device, actually. We're going to mount it from the file that we dd'd off of it. So we're going to do that. And then we're going to go mount. And now when we cd into mount, now we see this file system that we've extracted off of the device, and now we can explore this file system. So obviously, one of the first things we want to look for when we're doing some hardware reversing like this on a Linux system is we are interested in the shadow file. So here on the shadow file, we have a password hash. So it's blank. There's no hashes except for the Pi user. Again, if you're familiar with the Raspberry Pi ecosystem, Pi is the default user that is set up to be able to sudo without a password, right? Is effectively a full-blown administrator on the device, right? So this password hash is very valuable to us. So what I'm going to do is I'm just going to copy out the part between the semicolons, the second part there, which is the actual hash portion of this file entry. And then what I'm going to do is I'm going to go over to my GPU VM. So some people have a completely separate, station where they have a GPU for password cracking. I actually do something a little bit different. So I use, on Arch Linux, I have PCI Passthrough set up, so I can pass one of my graphics cards through to a VM, and then this is a big rabbit hole. This is extra credit if you want to go down this rabbit hole, but I also video game inside of a VM, and then I can either launch my Windows machine and play video games, or I can spin that down, and then I can give the GPU to a cracking station. And so that's what I have right now. So over here, we are going to, just create a text file. We'll call it, and we'll paste in our password hash. And now what we're going to do, so now we need to figure out the mode that we need to pass to Hashcat, which is the password cracking, the GPU accelerated password cracking software that we're going to use. And so what you need to do is we need to figure out this M flag, the hash type. And so now we're going to go to the most useful page on the entire Hashcat wiki. It is this examples page. And so what we're going to do here, because we see that our file, our hash here, starts with $6. Now, if you're a super genius, you just know exactly what kind of hash that is. I do not memorize useless information like that. But if I search for $6, I'll see here in the example section a hash that looks exactly like ours, and then that tells me this is SHA-256, 512 crypt, and the number, this is what we came here for, is 1800. So that means that over here we're going to run hashcat -m 1800. And then what we're going to do, now we need to specify two more things. We need to specify the password file that we're going to, or excuse me, the hash file, and then the password file that we're going to use. So what I have on my system is I have Daniel Meisler's sec lists, and I have just the passwords directory out of there. And so I'm just going to grab all the text files and, crack against that. And, oh yeah, it's going to tell me. So you would see something different here. So, oh, come on, let's have some fun with this. .rm. Okay, we need to delete a file. All right. Where is the pop file? All right, whatever. All right, we're gonna run --show because I already cracked this, right? That's what it's yelling at me about. So here we go. It was able to successfully crack the password, right? It skipped it because I had already cracked it on this system, but obviously this would crack very fast, and the reason is because the password is 12345. That is the super admin password on this automatic license plate reader. It is, username, Pi, password 12345. So that's pretty awesome. now what we're going to do is we're going to get this device set up, and we're going to confirm that we can get our shell on the device over SSH. So let's go to our desk. I'm going to power off this compute module, and we're going to pull it out of that breakout board, and we're going to get it back into here. Again, it's got this little DIMM slot. It looks like a piece of laptop RAM. There we go. We're all connected. I got my power over Ethernet here that we're going to hook up. And then I'm going to turn on my power over Ethernet. I've got this TP-Link, LOL, PoE injector. So yeah, so that's going to power that up, and we can come over here to our computer, and let's go back to this environment. Let's just ping that IP. Wait for it to come online. It is online, and now for the moment of truth, SSH pi at that IP address. 1, 2, 3, 4, 5. And we're in. We're into the automatic license plate reader. All right, and yeah, again, like I said, the Pi user can sudo without a password, right? So I'm just gonna stay as the Pi user. We're gonna do sudo ps avec blah blah. Okay, so this is gonna be interesting. Gosh, this is what I get for having small. Big text. So there's a bunch of programs that are interesting that are running on this device, and this is actually what we're going to talk about in the next video, because I want to really dig in and reverse engineer how this device works. In this first video, we're just talking about getting a root shell on it, which again, for a network device is a big risk, but I want to go further and figure out how some of these custom binaries work, right? SSH, that's like a configuration vulnerability, right? But to find custom vulnerabilities in this stuff, we need to look for where the custom, sauce is for this device and how it communicates out to the cloud and stuff like that. So I ran PS. Another thing that I'll run a lot with sudo, because you need sudo to add this -p flag to be able to see what program is associated with an open port, right? So port 22 here is associated with SSHD. No surprises there. But there are some services here on, 8080, the RTSP stream potentially on 554. These are all associated with this Avenger camera binary that's on this system. So this is, again, I've done a little bit of pre-work on this target, but suffice it to say that this is where all of the custom logic sits. It's in this, it's over here in opt is where I found this Avenger camera. Okay, so there's a bunch of custom scripts and stuff in here and configuration files, but the real thing that we're going to do next is we're going to jump into this binary and reverse engineer this compiled code, and to figure out how it works and potentially any other paths of attack on this device. So there's one more thing I want to look at, because if you remember from the Nmap scan, there is another service that's very interesting that is also can allow you to remotely affect the device, and that is SMBD. So this is a file sharing service. So I'm actually going to jump out of the SSH shell for a minute, and we're going to talk about, let's go back here to my folder, because I have, let's just make a directory called SMB. Okay, and then inside of here, let's make a directory called mount. So what I want to do is I want to attempt to mount a remote file share onto our system from this. And so what I found I was able to do is you do sudo mount -t cifs, and then we have to pass this option to mount where we specified username. So our username is pi, right? Again, we're going to utilize the same credentials for this attack, right? So, but we can go / the IP address 192.168. What is that? 3.103, and then we're going to say /pi. So this is going to be the mount point on this device, and then we're going to say my directory here, which I think should be this. Okay, and it's prompting us for password 1, 2, 3, 4, 5. And I think that succeeded, because now I can go into this mount directory and I can see the files here. Okay, so you can see those set of files there. Now let's give you big text, ssh pi at, paste that IP address, 1, 2, 3, 4, 5. Okay, so I'm back in my shell, and actually in the Pi's home folder, you can see that it is effectively, let's go through there. Yeah, oh, I have different text sizes. That's why it looks different. Okay, so you can see it's effectively the Pi's home directory that we're able to remotely mount with those credentials. So now we have 2 protocols that allow you to, read and write some files to the system. Obviously, SSH gives you more access, but this Samba thing is also a big deal. And so, yeah. So that's what I've got so far on this device. Thank you for watching this video so far. If you're not subscribed to my channel and you like this sort of thing, go ahead and hit that subscribe button, because that really helps me out, grow the channel, and get more impact with what we do here. I like to have fun, and if you like this kind of content, let me know in the comments. Let me know what other kind of devices you'd like me to look for. But keep an eye out for the next video in a little bit, where we dive a little deeper into this device. Thank you, and have a good day.